All right, I'm doing a couple of multiple choice problems from the 1998 packet for those of you watching, mostly just to review things. Sorry for the smaller version here, but I had to do it quickly. Number 3, slope of the line tangent to this. You're going to have to do things implicitly. So let's review. 2y times y prime, that's easy. When you have something like this, I advocate doing the power rule, 3xy plus 1 squared. Underline this because you have to multiply by the chain. And this becomes xy prime plus y equals 0. Now, you need to collect the terms that are multiplied by y prime. It gets a little messy, but all I did here was distribute the 3xy plus 1 squared times xy prime, and then that times y. Move this term to the right, and then collect these terms and divide. Then very carefully, the way I do these is I want to do it at the point 2, -1. I plug in everything. -2 plus 1 times -1, 2 times -1, blah, blah. And you should come out with 3/4. All right. Number 8. Oops. Stay up there. Which is a differential equation, but you see all the values of x are to the right, so you don't have to do any separating. You're just going to move dx over here and integrate both sides. Integral of 1 dy is y. That's easy. Now with this, you've got to recognize u substitution. U equals cosine x. du will equal negative sine x dx. So that will take care of the sine x dx with the negative. So the integral of this becomes negative cosine cubed x over 3. Now you could differentiate this pretty quickly. The derivative of cosine to the third of x is 3 cosine squared x times negative sine x, which you can see divided by 3 gives you this. All right, plus c. At this point, always use the value they're giving you where they tell you y is 0 when x is pi over 2, so you can solve and get c equals 0. So the specific solution is this. And then they ask you, what about when x equals 0? Cosine of 0 is 1, so it becomes negative 1/3. One more for you. Where did it go? Number 15, because you're weak on integration by parts. So this is a bit of a review. But remember, if I have x cosine x, there's no substitution I can do. And I would point out, if I had cosine of x squared, then I could let u equal x squared, and I'd have du equal to 2x dx. Do you see? And getting the 1/2 would take care of this, and then I could do it. But here I've got x cosine x, so I have to go back to, remember with by parts, LIPET, logarithm, inverse trig, polynomial, exponential trig. That sort of gives you, it almost always works, the order in which you choose your u. So, in this case, I have x is a polynomial, and that certainly becomes before the trig cosine x. So I let u equal x, dv equal cosine x, du is 1 dx, v equals sine x. So this is equal to uv minus the integral of v du. I wrote that out for you. You got to have that in your back pocket. So that's x sine x minus the integral of sine x dx, which is negative cosine x. So this will end up being x sine x plus cosine x plus c. Now, I did the Sam Hooker check. X times cosine x plus sine x plus negative sine x equals x cosine x. That took 10.2 seconds. So worth it on a multiple choice problem. All right, see you tomorrow.